You have lots of time because I know.
Yeah, that's true.
Hello, Assalamu alaikum. Namaste.
Alaykum salam, sir.
Walaikum salam, sir.
Abdullah, Abdul Ghafoor, Manisha, Bashirul. Only 4 people.
Yes, sir. Others will join, I guess.
I to 20 मिनट में ज्वाइन करना तो फीस अगर सब 20 मिनट समझा देना.
Okay, so Ghafoor, you can write on WhatsApp that please join. Master is already there.
सही है भाई.
Okay. Okay, so I'm sharing my screen. Okay, so before we start, I hope you remember where we left last class. What was the last topic, Manisha?
Sir, autoencoders.
Okay. So, Hasib, Manisha, you can switch off. Okay. Hasib, do you have any question from previous class?
No, sir, I just saw the video and it was all clear.
Bisharul, how about you?
No, sir.
Certain?
Yes, sir.
Okay. So today we'll start this final topic. Again, a very exciting area in deep learning. It's a kind of generative deep learning. We have already seen how text is generated by using LSTM. In today's class, we'll see how images are generated. Because you might have already seen this person does not exist. They are actually generating images by using GANs. So today we'll see how GANs are operating. We'll see their basic principle and we'll see their implementation. And then last 30-40 minutes, we will just give a quick review to whatever we have done throughout this fall 2020. This has been a long semester. I mean, COVID has kind of disturbed us. I also went through personal tragedy. But nevertheless, this is the last class, and I think your final exam is on Friday, the coming Friday. So this is the last class before we will have final exam next week. 3 things are due on you from my side in this course: your final submission of the course project, the assignment that I will assign today, and the final exam on Friday. Your one thing is due on me, your mid-exam result. I have already assessed all the copies. I just need to reconnect. I think only one or two is left. Somehow, this assessment has gone into background. But hopefully, before final exam, I will share your final result. But the good thing is, almost all of you have scored between 18 to 20. That is also the reason why I have been a bit relaxed. I know that none of you will be considering the option of withdrawing from course. You have already put a lot of efforts in this course. So hopefully before final exam, I'll be showing you your final result as well, the mid result. And I will also do all the calculation of your assignment submitted to so far. So hopefully before final exam, you will see your 60% result. Okay, so generative adversarial network. Just 1 minute. There is Azan on my side. Okay. So today we'll see introduction of GANs, and then we'll see implementation of deep convolutional GAN and conditional GAN. Before you see anything else, I want you to see this video on YouTube. These are actually the wonders of GAN. So certainly all these things you can do with GAN. These people do not exist. These people have all been, generated. I mean, we have been wondering throughout our life how God creates unique people. We have seen, I mean, just 7, 8 features: nose, mouth, forehead, ears, just few things. But see how many, combinations are there. It's only unique ability of God, but at least at the image level, now we people are also able to generate unique faces. I mean, faces which never existed in past. All these, are the faces which never existed. It requires a lot of training, 10 hours of training. As training time increases, you can see the synthetic of image also improves. So you can see all these are actually wonders of GAN. Let's see how actually it works. See how simple the idea is. I mean, the principle of GAN, it has got two sides. One is the generator, other is the discriminator. Very simple. I mean, the generator is a kind of this bad guy who actually prints fake money. Then discriminator is a kind of expert guy who can differentiate between fake and real money. So there is always a war between this generator and discriminator. This generator want to make a discriminator fool. I mean, this process continues until this discriminator guy finally says this is the real money. So you know, this whole process will start when generator will generate a random image. This guy will be able to, you know, distinguish between that random image and the real image. So obviously this will give a kind of feedback that this is fake, right? When it gives feedback, it also tells this generator what are the you know, areas where there is the improvement required. I mean, this will also identify the areas why that money is fake. For example, when you see a currency note in Pakistan, you can easily identify that this is fake, because usually on fake money you will see Eid Mubarak. So as soon as you see that fake note, you will say, ah, this is fake, because you have Eid Mubarak written there, right? Or maybe even if you remove Eid Mubarak, if you generate a new currency, you will see, you can give a feedback that the paper of this you know, currency note is you know, different from the original. Sometimes you can give feedback on the color, or sometimes you can give feedback on a, you know, small thin wire that actually runs through the currency note. So all these inputs, I mean, you have a generator which is all the time generating a new image, and this guy is actually an expert, a kind of classifier which is already trained on fake and real images. Its feedback, you know, is important. It is not only giving you feedback that this is fake, but this is also giving you feedback why it is fake. So it will be kind of identifying the, you know, defects that can be seen into that newly generated image, right? Please start recording. I think it is recording is already on. Saif, recording
Yeah,
is
yeah,
already on.
it's regarding, it's regarding. I just,
Yeah, it's already recording, eh?
yeah, yes.
Okay, so you know, this guy is always generating a new image. This guy is going to give feedback why it is fake, and this war will continue until this guy finally admits that this is a real image. At that time, you know, rest of the life, this guy can be, you know, printing all those fake monies and become a billionaire, right? So that is the basic principle of you know, GAN. In GAN, we have a generator network and we have a discriminator network. So these two networks are cooperating each other just to you know, generate images which look very real, right? Here's the basic principle. You can see here. You can see here. Ghafoor, Hasib, Abdullah, Bisharul, Manisha, Khalid. Okay, okay. Okay, so you can see here, it starts the noise. I mean, what a great idea. You just have an initial noise, huh? Nothing, just random pixels. Those random pixels are given to generator network, which generates a fake signal, a kind of fake image, right? Now, this and the real image, both of these are given to a discriminator. So discriminator will actually discriminate. It will initially be, you know, trained. This guy will certainly be trained on both real and fake. Maybe you can show him 1 million real notes and 1 million fake currency notes, right? So when he sees too many real and fake, you know, currency notes, it will eventually be able to differentiate between fake and real. Manisha, go ahead.
Sir, what's the purpose of giving noise?
Yes, I mean, you need something to start with. You need something to start with. So initially you will be giving it nothing, just a random image, an image which has nothing, just, you know, pixels with some random distribution. So we need to give it noise. So you can say this is the for example, when you talk about currency notes, so in that case you can imagine this initially is nothing, just a white paper, right? So you are asking this generator to generate a currency note from the white paper. Now you know that when it gives white paper to the discriminator, at that time, because discriminator is already well trained how to differentiate between currency and white paper, so it will certainly tell you that this is not a currency note, it's a white paper. So at that time, it will tell that it is a white paper. It means that it knows that I have to change the color, right? So this process maybe for 1 million iteration, maybe for 10 million iteration, it is continuously sending an improved version of currency note, and eventually, this guy, discriminator, will say, yes, this is true, this is the real note. So at that time, we will probably eliminate this part of the network and just retain this part of the network, which is generating new images. So we need to give noise because we need to start with something. So noise may not be the very right word selection, but the thing is just a random image, any image. So say for example, I mean, if you see this one, if you want to generate numbers, so we started from here, or maybe not even from here, but if you see saved images, look at this one. Now see, you wanted to generate a human face. Now when you want to generate a human face, you need to start with something. So you can see initially we gave nothing, just this image, and this is nothing, just random pixels, a random RGB combination. So when we gave this, it gave us input, we improved, we reached here, we improved, we reached here, we improved, we reached here, we improved, we reached here. So you can see as we move along, slowly, gradually, we are improving and we are able to generate human face, right? So the important thing is, when you say that we want to generate a fake image, you need some input. Now the question is, what should be that some input? Where to get a start from? The answer is start from a random image. And when I'm saying random image, it is nothing, just a noise. Just if you are a kid, you just draw some random lines, right? So it is important that you provide some initial random input so that it can eventually work on that. I hope you're clear, Manisha.
Yes, sir.
Okay.
Sir, actually, noise word is confusing for me.
Yeah, I understand. I mean, that's why I said noise may not be the right word, but the thing is, it is just something initially random. And I have shown you the example when we were working for our face generation. We started with these images. These are not faces, but we need something initially. So maybe if I'm asking my kid that tell me if I have generated a good beautiful face, so I will show her a page like this. So she will say, no Baba, this is not a human face, huh? So when she says this is not a human face, she will also tell me why it is not a human face. She will tell me, come on, there is no sketch, you need to draw something on this so that I can give you feedback. So maybe I take this page back, and then I maybe initially do something like this. Now I say, do you think this is human face? She can give me input that, well, this is human face, it has got two eyes but does not have nose. So maybe I then can draw another line. I say, here is the nose. He might tell me again that it has got two eyes, one nose, but does not have mouth. So she gives me feedback. So with that feedback, I also add mouth, and then this process continues to improve my drawing. I mean, this is exactly how we have learned in real world. I mean, in real world, I am able to distinguish between real and fake money because I have seen a lot of real money. And when you show me a fake currency note, I can in the blink of an eye, I can tell you if it is real or fake. So, it all because we have experience of differentiating between real and fake, we are able to do that, right? But, we have acquired this training seamlessly without actually taking note of it. But our neural network is trained because we have seen a lot of data. So if you want that your deep learning neural network should be able to achieve same thing, then you need to provide them a lot of data. So that is the reason why we need to train the network. So here is the process, the actual process. Now this is during training. Remember, this is during training. So during training, what we are going to do, we have got a discriminator, which is nothing. Remember, this is a thesis idea. I mean, a kind of very good research area, which is very less explored. So you have got a distinguisher, you have got a classifier, which does nothing, which only tells you, if you give me an image, I will tell you if it is fake or real. For real, label might be 1. For fake, label might be 0. So you are, I mean, this network is able to tell you the difference between fake and real, because it has seen many real images, many fake images, right? So this discriminator will initially be trained by getting actual data, and then by getting noise data from this generator side. So it will do nothing. It will train itself, set some parameter, so that it is able to do differentiate between real and fake. Now remember, when you are playing with the image, you will have CNN here, but when you want to do text generation, then you can have LSTM here. And believe me, these GANs have mainly been used in image generation, but text generation side on GAN, there are few good attempts, but still that area is not very much explored. People have seen text generation from other perspective, but not from the GAN perspective. So a text GAN is one area which is very recent, and there are some attempts to it, but still that is not very much a mature area. So you can contribute on that side. But the thing is, you will have a discriminator, which is nothing, just a classifier which is able to tell you if you have given me at the input a real image or fake image. Yes, Irfan?
Sir, on text processing side, if you use GAN, what could be the discriminator? Language lexical analyzer, which can just check the grammar, or how it will verify there's a text, and it's a well-written text.
You mean which will be generator or discriminator?
Discriminator.
Okay.
Because at the generator side, we can train LSTM to generate text by flooding seed. We have done this.
Right.
What would be this discriminator actually?
Very good question, Irfan. Excellent question. The answer is we have both options. What we will actually do, through this guy, we will give billions of sentences which are grammatically correct, and to this guy we will give billions of sentences which are grammatically incorrect. So then we are hopeful this process will have to work the way we learn our mother tongue. We have never been told in Sindhi what is subject, what is object, what is verb. But even before reaching 5 years of age, we were very fluently speaking correct Sindhi, right? And in Bashirul's case, I think correct Tamil. So the thing is, we are able to speak our own language correctly because we have seen a lot of correct Sindhi sentences. That is the reason why we are able to speak correct Sindhi, right? So in this case, if you want your network to be able to distinguish between correctly generated text, you just need to show him millions of instances which are incorrect, millions of instances which are correct. So hopefully this structure will be learned by the discriminator, right? This is one approach. The second approach is you generate millions of sentences, do their POS tagging, and send that POS tagging combination to the discriminator. And the POS tagging combination from the actual text is coming from here. So maybe millions of correctly written English sentences, their POS tagging is coming from real data, and the POS tagging of this fake data, we are showing both to this one. So next time when we generate next sentence, we see if our discriminator is telling us probability that the sentence is real. If it says it is real, then certainly the generated text will be correct. So the thing is, that is the reason why I said this area is not very much explored from the text perspective. From the image perspective, people have done a lot of work, but from the text perspective, GANs are yet to be, their full potential is yet to be, realized. Right. So the important thing is, this is the training process. Now just see what we are doing. It is important to understand the concept, because if you do not understand the concept, then understanding its programming will be very difficult. You just need to understand the process, see the process. We have this discriminator, which is nothing, just a CNN classifier. We have already seen CNN classifier. It is getting real data and it is getting fake data. So the real data has got label 1 and fake data has got label 0. We are going to train this network on real and fake data so that this becomes expert, so that this becomes a good discriminator to tell us if the image at input is real or fake. Right. Now, at the time of training, what generator is doing? Generator is doing nothing. It is just generating random images and supplying those to the discriminator. So end of the training process, this discriminator will become an expert to differentiate between real and fake images. Between real and fake images. Right. Now when training completes, see what we are doing. Wow. Now we are not supplying, because this is expert. It has already trained. So we will freeze its weights. We will freeze its weights. I mean, now discriminator is no more learning. It has completed its learning. Now the only thing that we are doing, we are generating an image and we are giving label 1. Label 1. We say, we tell to discriminator, the image that we are generating, it is real. When we say it is real, discriminator will have very high loss value. Discriminator will tell you, no, it's not real. It is not real. Because if you say it is real, my loss value becomes very high. So certainly at that point, when we say this is 1, but actually it is fake, loss will be very high. And when loss is very high, we do nothing, we do gradient descent. We try to minimize loss. It means that now our whole focus is not to change this label from 1 to 0, because it's a kind of our insistence. Is it dead? This is real, this is real, this is real. When we claim this is real, discriminator will give you very high loss. When it gives you very high loss, you actually do gradient descent to figure out how to minimize that loss. As the loss value goes down, different pixels will be playing with in the fake image just to modify their values, to modify their intensities, to modify their RGB, contribution. Eventually, this image will be taking a meaningful shape. This image will actually be turning to become a real image. So there will be a point when you will see that, loss value is very minimum, and you will start seeing images which are generated, but they will look very real. Now, the thing is, there are millions of pixels. So certainly generating an image which is already existing, the probability is very low. The probability is very low, because you can imagine how many combinations are there. If you have got, say for example 1024 by 1024 image, and you just change one pixel at a time, you can imagine how many different possibilities are there. So certainly generating an image which is coming from the actual data set, the probability is very high, but at the same probability is very low. But at the same time, because we are improving, pixels value, so that discriminator at some stage can tell us that yes, this is the real image. So obviously the standing of this generated image, the look and feel of this generated image will be very real. It is just like there is a banker who has spent maybe 20 years in the bank. You are showing him a fake currency note. He will tell you, well, this is fake because these are the defects. So you take that note back, remove those defects, come back, tell him again. He will again tell you this is fake This is fake because these are other effects, other defects. So you take that note back to your home, change it, come back. So if you maybe do 1,000 times, eventually that banker will tell you, wow, this is very real. It does not look very fake. So the whole idea is you will have to continuously improve quality of your generated image so that eventually you can make this discriminator full, so that eventually you can minimize the loss when the label of generated image is 1, right? So this is the whole idea of this GAN network. And if you see from the deep neural network side perspective, initially a 100 dimension z vector, nothing, just a vector, random number, nothing, initially random number. We convert those random number by using this dense neural network from 77 to 128, right? Because this one is we want to generate handwritten numbers, handwritten the images for handwritten number, right? So we start with the dense 77128, we reshape them in 77128. We have batch normalization and ReLU, the activation function, right? And then we do convert 2D transpose. I mean, usually when you have in a simple convolutional layer, you usually are given image as input and you want to predict a label. But the inverse of that convolution is this convert 2D transpose. So it is actually doing nothing. It is kind of getting numbers and converting them in image. You can say this is the kind of inverse process what we do in convolution, right? So we have convert 2D transpose. It actually it does stride by 2, a filter size of 5, and its output will be 128. Then again activation, another layer of convert 2D, activation, another layer of convert 2D, activation, another layer of convert 2D, and then we do have sigmoid, right? So end of the day, this network will actually be doing nothing. It just takes noise at the input. I mean, just random a vector of 100 dimension at the input, and with the help of convert 2D and activation, it is giving you an image. So certainly initially this might not be very beautiful. This might be just all black pixels or all white pixels or randomly some black some white pixels, but that fake image is going to be sent to the discriminator, and discriminator is nothing. You can see here it just have got an activation, then convolution, activation, convolution, activation, convolution, activation, convolution, flatten, dense layer of 1, and then sigmoid. Just a typical CNN network which can differentiate between fake image and real image. So you can see in practice, from the programming perspective, from the Keras perspective, it is nothing. Just two separate network, one network for generator and one network for discriminator, right? So we will develop two network, one for generation, one for discrimination. We'll see how they work and how we will put both of them together, right? So we'll first do this, the training, and then we do this, the generation, and both of them obviously this G is this one, the discriminator, and this G, the generator, is actually this one. Because you can see this takes 100 dimension vector, a random vector as input, as you can see here, the random vector is input, and it generates x dash. It generates, this is the x dash, right? And when we were here, we were training discriminator, right? So you can see here, these are the real images, these are the fake images. Initially we are going to train the discriminator, but when the training process completes, we will have this type of a structure where we have removed the real images. Now we are just generating fake images and trying to minimize loss on the training images. So you can say we've got two trainings. The one training is for the discriminator, and the other training is for the whole adversarial network. You can say whole GAN network. right? So we will train the model twice. Once only discriminator model will be twice and will be trained, and the second both of these networks will be only GAN will be trained, right? Have you got the concept? Question?
Yes, sir.
Yes, sir. Yes, sir.
Okay,
No question, God, sir.
great, great. Khalid, are you there?
Yes, sir. I'm here, sir.
Okay, okay. So I hope you are clear with the concept, right?
Yes.
Okay, okay. So we do not have Kainat, we do not have Noreen, and who else is missing? Nimra. Nimra says she will be late. Eh? Any other guy missing? I think that's it. That's it. Okay, now let's see the implementation. You have to be with me because this is very tricky. Eh? You need to understand it. Point one. Point two, you need to understand because of this reason. Because of this reason. I mean, this really is not an option, but it is mandatory to understand whatever I'm covering today. Assignment number 6, CGAN. It's nothing. It's based on what we are covering today. I am going to cover example of MNIST, but I'm expecting that you will do it on Cypher. I'm asking you to generate a frog. I'm asking you to generate a frog image. I'm hopeful that you'll be able to do it by Jan 13, 2021. So, if you are not fresh, you have to have some water on your face so that you can understand this concept fully for one obvious reason that this assignment is due.
Sir,
Yes, sir.
please extend its date. We have exams from Monday.
You have
Yes,
exam
sir.
from Monday.
Final exam. Yes, sir. And
Okay.
we have
So
4 subjects to cover.
in that case, I think I should bring it earlier because these 2 days you have Saturday and Sunday.
We will have to prepare for exams as well.
How many courses you guys have? I think 3 courses.
Sir, I'm taking 3.
Yes, sir. 3 courses.
I think almost everyone taking minimum 3, and some might be having 4.
Well, we'll discuss on it. I mean, this has been a frequent pattern of our course. I set a deadline and you guys extend it.
No, sir.
Okay, okay. So here, let's see how we can generate handwritten digits. How we can generate handwritten digits. So certainly for that, we need to show our discriminator how digits look like. So the first step will be to show digits to the network, to tell the network how digits look like. So for that reason, we will be training this model on MNIST, right? And MNIST has been our a good friend from the very first day, right? So here, after mounting my drive, because I will be writing back to my drive, so I need to mount it. I build a generator. Now I have a method, I have got a function for building a generator, and then I have got a function building a discriminator, and then I have got a function to train, right? To train the model, right? And then I am also, plotting the generated images, and that's it. That's it, right? Just 2 to 3 simple functions. So here we start with the build generator. Now this build generator, you know what generator is doing? Generator actually, if you look at this thing, generator takes a random vector and it generates an image, right? So that is the reason why, if you see in programming, it has got input, which is a random vector, and it generates an image of this size. It generates an image of this size, right? Now we'll be sending here the image size 28 because our MNIST is 28 by 28, right? But if you see, our generator actually starts from 77 to 128, right? It initially generates a very low quality image, then it starts improving its quality. Eventually, it will generate 28 by 28 by 1 image at a time. Right. So here we say that initially it takes this random vector and it converts this random vector in 7 by 7 by 128. We reshape it to make it an image 7 by 7 by 128, and then activation, and then convert 2D transpose, activation, convert 2D transpose, activation. So all these steps which we have written here, we are doing them programmatically here. So because the image size will be 28, so I divide it by 4 to make it 7. The kernel size is 5. This is the filter size. As you can see here, the filter size is 5. The filter size is initially 5. And stride for first 2 layer is 2, and for the later layer it is 1. Right. So you can see here the filters that I have 128, 64, 32, and 1. Why? Because if you see, I start with 128, right? Then 64, then 32, and then 1. So that is the reason why I've got these filter size. So, again, this is functional API of Keras, and functional API of Keras, this is just like I'm creating a layer, and to that layer, I'm sending this as input. So this input which I receive from here, I'm sending that input to dense neural network, and that dense neural network is actually, image size which is 7 by 7 into initially 128. So you can see here 7 by 7 into 128. So this is the first layer. I reshape it, right? I reshape it to make it 7, 728. And then I have got this loop. In this loop, I'm doing nothing. I'm just adding this combination for 4 times, for 128, for 64, for 32, and for 1. So you can see here, I say for filter and layer filter. So initially 128, then 64, then 32, and then 1. So I say if filter is greater than filter at -2, which is actually 0, this is -1, this is -2. So if it is greater than 2, I mean when we reach here, when we reach to 32, you can see here the stride is 1. So that is the reason why we say when this reaches to 32, if it is greater than 32, then stride is 2, otherwise stride is 1. A simple logic, because I have got stride 2 here and stride 1 here. Right. So we do stride 2 and stride 1 based on what is filter size. Then x equal to, I pass input to batch normalization, right? This is the activation, and then this x after batch normalization I pass to reloop, and this x after reloop I pass to convert 2D. So for first time the filter size is 128, right? So 128, kernel size is 5, stride is 2, padding is same, and I'm giving this my input. Right. So this is during first iteration of for loop. And second iteration, you can see again stride will be 2, batch normalization, activation, filter size will be after 128, 64. Right. So 64, next time 32. When it is 32, stride will be 1, because you can see here when it is 32, stride equal to 1. Right. And when I go back, I bring 1 and stride equal to 1. So when this loop ends, we are actually here. Finally, I add sigmoid. I add this, activation of sigmoid. I add this activation, and then I say generator is equal to create a model. And what is that model? It is X. My whole model is stored in X. So X is actually representing this model. And to this model, the input is actually coming from here. The input which I'm getting when someone is calling this function, and name it generator. Name it generator. So when you call this method, it will be doing nothing. It will just, you give input, you tell me the image size, I will give you generator. I'll give you generator. Clear? Very simple, very easy. This is the generator side. Irfan, question?
No, sir. Clear, sir.
Okay. Very good. Excellent. Someone has unmuted the mic.
Safe, sir.
Okay, okay, okay. As usual, eh? Okay. Now we
I'm alone in my office, sir. There is no noise.
okay. So, do you think that if you switch on mic, you will be going to heaven without any hisab kitab? मतलब mic ज्ञान का सवाब आया. Okay.
I was basically giving response.
Okay, okay. Now we are building the discriminator. Eh? Again, if you watch it for discriminator, the input is obviously an image, right? And that image has to be 28 by 28 by 1, right? To that image, we are doing nothing. We are just telling if it is fake or real. So this discriminator will be more like a typical CNN. So input will be input layer of the discriminator, that is the image. In this case, it has to be 28 by 28 by 1 because we are playing with the MNIST, right? And it returns a discriminator model. So initially, the filter size is 5. The layer filters are, typically what we do in CNN, 32, then 64, then 128, then 256. So X equal to input, filter equal to, far filter and layer filter. If that is -1, then stride is 1, otherwise stride is 2. Same logic as we have seen previously. You can see stride is 2, then stride 2, then stride 2, and then stride 1. So that is the reason why same thing we are doing here. X equal to, ReLU and leaky ReLU, both of them are activation, just small change in their equation, but again it's nothing, just an activation function. Right, so we give X to leaky ReLU, and then we add the convolution layer. You can see here we have that traditional convolution layer, because again here we are kind of converting image to a label, but from there we were converting a vector to an image. So when you are going from vector to image, you need to do that convert to the transpose, but when you just want to get one label for the image, you need to use a typical CNN. So in this case, it is again a typical convert 2D layer. The filter during first iteration will be 32, second iteration 64, third iteration 128, and fourth iteration 256. When this is done, I just do flattening the way we normally do. You can see I have just flattening, a layer, and then another layer of fully connected out with output 1, right, and activation sigmoid. And my discriminator is actually this whole X, right? You know that in this X I've got everything, passing inputs, and I give it name discriminator and then return the discriminator. So whosoever calls this method, this one will give us inputs, will give them image, and whosoever calls this method, it will give us an image and will give it the the discriminator. Yes, Asif, you have got question?
Yes sir, वो जो आपने पॉइंट डिस्क्राइब की ना डिस्क्रिमिनेटर पार्ट में कॉन्वोल्यूशन 2D पे लेबल वगैरह की, वो थोड़ी समझ नहीं आई थी मुझे.
Can you say it again? I lost couple of packets.
X equal to con 2D, यहाँ पे एक पॉइंट आपने डिस्क्राइब की थी, वो मुझे समझ नहीं आई.
See here, Asif, this one is typical CNN. This is nothing, just CNN. In CNN, we have been doing sequential API. Up to this point, we have been using sequential API, but this one is functional API. In functional API, effect is same. Behind the scene, things are same. The only thing is it uses functions. So you can see here, X equal to convert 2D. We are actually calling a function, and to this function, we are passing parameter which is X. And what is X? X is this one, which we have just calculated. And to this function, we say these are the additional parameters we are passing. Filter, initially 32, then 64, then 128, then 256, right? So filter, every time value will be supplied. The filter size, in convolution, you've got image and you've got filter. So this calls it kernel. This book actually calls this kernel size. In our previous book, we are calling it filter. but this is the filter size. So this is 5 in our case. You know, we usually have a filter of 3 or filter of 5 or filter of 7. So same filter we are supplying here, and stride, you know why? Huh? Stride we do just to downsample the image. So this is same CNN that we have seen in sequential API. The only change is this is functional API, so code is a bit different. But otherwise, we are doing nothing. We are just adding all these layers: activation, convolution, activation, convolution, activation, convolution, activation, convolution, flattening, dense, and then finally activation. Right. This is a typical CNN network. We have already seen in our sequential API. But here, this is in functional API. And they say functional API is easy to understand. Might be, your opinion might be different. But the thing is, these two are the ways in Keras you can create a network, either by sequential API or by functional API. When you're working in sequential API, you will start with model equal to sequential, and then you say you will be adding, you know, a model dot add layer, model dot add layer. We have been doing it in our sequential API in previous classes, but here in the functional API, we do it with different. Right, but it is ultimately nothing, just a CNN. Clear?
Yes, sir. Yes, sir.
Okay, great, great. Now comes the actual work. Believe me, this is a bit tricky, so you have to be with me. I mean, you have to fully concentrate on whatever we are going to cover now. We've got this method, build and train models. We load MNIST. Why we are not loading labels? Abdullah?
At the moment, we don't need them. We just need the images so we can train our model.
We just need images. We are not doing classification that we also need, you know, wide train. No, we do not need it, because we just images. We want to show to our GAN how handwritten images look like, because this is not a typical supervised classification problem. This is actually a problem in which we want to show our GAN how handwritten images look like. So certainly we don't need Y label. That is the reason why I'm only loading X train. And you know, these are 60,000 images. These are 60,000 images. Right. Image size, you know, if I write here, I just want to test your understanding. Image underscore size equal to X underscore train dot shape. Manisha, what do you think? If I do this, what will be value of image size in this case? Manisha. Yes, Manisha, are you there?
Connection loss.
Value of image size. If I do this, I just want to trace understanding, how much understanding we have developed. Irfan, what do you think?
28 by 28.7. I think we said this earlier.
If I only get 0, if I only say 0.
Sir, I guess it would be the number of images.
How many?
So 60,000.
60,000. 60,000. You're right. 60,000. 60,000. So there are 60,000 images. So that is the reason why the first value is 60,000. So there are 60,000 images of 28 by 28 by 1. So you're right. It has to be 60,000. Anyway, image size we get 28. X train np.reshape X train to all these images we convert in 28 by 28 by 1, and then we do this thing just to normalize these values from 0 to 255, 0 to 1, 0 to 1, because they have intensity value, but we want to confine it from 0 to 1. The model name, any name, I call it deep convolutional GAN, right? The latent size initially 100, the input dimension vector, right? the size of the input dimension vector. So I give it 100. The batch size, I mean 64 images at a time will be taking to train the model. The training steps, 20,000. This is, I mean, higher the number of steps, better will be the understanding of the model about the images. Learning rate, and decay, both of these parameters are completely arbitrary. You can learn it from experiments, but these two actually give reasonable result. So our input shape equal to 28 by 28 by 1, right? Our input equal to input shape is equal to this, and to this we give name discriminator input. Discriminator is equal to, I'm calling method discriminator equal to build discriminator, and I'm passing this input. When you build a discriminator, you can see here, this is your build discriminator. It gets input and it returns you discriminator, which means that in discriminator now we have got complete model for our input, right? And then I have this optimizer with learning rate and decay. The discriminator, I compile it with binary cross entropy, and then optimizer, RM's prop, and matrix is accuracy. I just display its summary. When I display its summary, you can see when I ran it on my machine, it took a lot of time, not a lot of time, but just 10 to 15 minutes to complete 20,000 steps. Okay, when I display its summary, you can see here, come on, streaming output. What happens? I don't know why, but it's anyway, you can see this is the summary. This is the summary of discriminator. It should be displayed here, but for some strange reason the earlier output is not visible. The earlier output is not visible. Anyway, I can run it again. So I'm running this, right? Yes. Okay, this. Okay. Allow. Okay, I copy this, control V. Right. So this is just function, so it should not take a lot of time. Just 1 second after mounting. Okay. The steps which I have set, once if that is done, come on. Okay, that's it. Then the second function, build and train model, number of steps, just to finish execution quickly, I do 8,000, right? So when I run it, this is the function of discriminator. Okay, build and train, So discriminator, I compile it, and then I display its summary. So I run this and you should see the summary. But this is a function, I haven't yet called it. I will call it later on, right? So you need to understand, we have created discriminator here. Yes, we displayed the summary. I will show you summary when we actually call this function. I mean, it's not displaying because we are not calling this function. We have just defined this function. So we'll call this function and then we'll see the summary. Again, here now when the discriminator has been created, now we create a generator. So input shape is equal to the discriminator. The input shape is this. So you can see we pass 100, input equal to, we say shape is equal to 100, and we call it discriminator input, Z input. Generator, we say build generator. You can see here, we say with this input we need image size. Image size means 28. So we call build generator. So you can see our method of build generator has been called build generator. It takes input and it gives you, it takes input and it takes image size and returns you generator. You have already seen this code, right? So we get generator, we display the summary of generator also. So display summary of discriminator, display summary of generator. Now we set optimizer for discriminator, optimizer, not the third step. Now remember, discriminator is created, generator is created. Now is the time to put both of them together, to have, you know, a kind of adversarial model like this one, like this one, in which both of them are put together, Now remember, when you are in adversarial mode, when you have already trained your discriminator, at that time your discriminator, you know, must not be trainable. I mean, at this stage you can see here, I mean, here you would not want that this should also be updating its weights, because that does not make sense, because we have already trained it. So that is the reason why we say that in the adversarial, the weights of discriminator are not updatable. It is just like you are giving a currency note to a banker. He is already trained. At that time, he cannot say that, well, I'm not sure, let me dial to my boss if this is real or fake. I mean, at that time, the banker cannot update its training. At that time, banker cannot acquire new knowledge to differentiate if it is a real currency note or a fake currency note. So certainly, at that time, the training of the banker should be final. At that time, he should not be acquiring new knowledge. So that is the reason why we say that discriminator trainable is equal to false in the adversarial. So adversarial is nothing. We just provide the input, and that input is given to the generator. Generator will generate image, and discriminator will tell us the label of that image, right? But obviously, when we are working in the adversarial, the label that we will provide will be 1. So discriminator will have very high loss initially, because if it is only some random pixel, then at that time the loss value for the discriminator should be very high, right? So we compile adversarial, we have accuracy as our matrix, and then we see summary of this model, right? So all three models is equal to generator, discriminator, and adversarial. Parameters is the batch size 64, latent size 100, training steps 8000, and model length that you are passing. With all these three, everything is set. We are calling method train. So in this case, build and train the model. We initially build discriminator. Then we initially build. We just load the training data. Then build discriminator. Then build generator, and then put generator and adversarial both together. I mean, generator and discriminator together to make a adversarial network, right? Once this is done, now we are passing models and training data along with parameters to the method train, and see what method train is doing. Here is the final method, which is the method train. In models, we have got all, you know, three models: generator, discriminator, and adversarial. This is our training data, and these are our parameters, right? So we unfold models to get generator, discriminator, and adversarial. We unfold the parameter. All these parameters, you know, we store in individual variables. Then after every maybe 500 steps, we are going to save output of the model. We just want to see because if you display it after every one step, you will be displaying 8000 images. I mean, interpreting those 8000 images will be very difficult. So we say that you learn after every 500 steps, you display the output that you have generated so far. So certainly it will be improving with every step. You can see here, these are the images after, you know, increasing the training steps. So I say save interval is equal to 500. Then noise input. This is how we generate noise input. We do nothing. We just generate random value from -1 to 1 of the latent size, right? So this is noise input through numpy, random uniform distribution from -1 to 1, 100 dimension, and we do nothing, just generate this vector, right? Which a training size equal to x train dot shape of 0, which is obviously 28 by 28, and then for I in range of training steps, we do training. This is kind of one epoch at a time, eh? So what we are doing now, we need two things. The one, first we need to train the discriminator. So we are in this phase. We are in this phase. First we will be in this phase, and then we will be in this phase, right? So first, when we are in this phase, when we are just training, so what we do, we randomly take some images, from the training data set. How many? 64 at a time, right? So from 0 to training size, and randomly take 64 images, right? Those images we take from the X train and save in real images. So you can say these are the real images, the X, this X we have prepared, right? Now the noisy images, we are now generating this one, right? So we do nothing, we just say that generate random images, value should be from -1 to 1, and size should be 64 images, and each of them should be of size 100, right? So 64 images we take from the real data set, and 64 random images we generate by numpy.random.uniform through uniform distribution, right? Now what we are doing, fake images is equal to, we give this to the generator dot predict from the noise. So obviously what we are doing, we actually give the z to this g, right? And this g will give us x dash, right? So we get these fake images from the generator. Certainly initially these will be very bad, just some random a uniform distribution of pixels, but as we move along, the synthetic appearance of these images will improve, right? Now what I'm doing, I say x equal to, we are concatenating real and fake images, so that we can train the model, right? X equal to all images, real as well as fake, and y equal to, we assign 1 to label 1 to all the images, but later on we say from batch size till the end assign them 0. So label 1 for real images and label 0 for fake images, right? So we have kind of generated one batch for training our discriminator. So this X is actually having real images as well as fake images. Real images we have taken from the training data set, and fake images we have got generated from our generator by passing it this vector, and the vector we have generated randomly. And how many vector? Vector of batch size, and each of the vector is of size 100 dimension. So all these vectors, one vector at a time, we gave to the generator, and generator gave us all those 64 initial random images. So those random images as well as real images, we concatenate, keep them in X. Our Y, initially we assigned 1 to all of them, but later we change from batch size, from 64 to the end. So then we assign label 0. So you can see here, when we are training, x dash is given label 0, x is given label 1. So that is the reason why we say label 1 is given to the real images, this one, and label 0 is given to these images which are fake images, right? Now based on this, we say discriminator, which we have already created, we say train on batch. This is just like fit method, right? But we are kind of, because training it on a batch, so we are using, rather than fit, we are using train on batch. So we provide x and y. So this is just like This is just like we are showing our discriminator how real and fake images look like. This is, we are training our discriminator. We display its loss just to see how it performs. Right. Now, once on the first batch, when the discriminator is trained, see what we are doing now. We say noise equal to, we generate another set of 64 images. All of the Y's are given label 1, and to the adversarial we say tell us your loss, right? So now, rather than training the discriminator, we actually train our adversarial. So we say to the adversarial, these are the noisy images. You have already seen how real look like. Now tell me, what do you think? Are these real images? If initially loss value is very low, it means that our model has not learned properly, because it is just like a banker. You show him an Eid Mubarak, currency note, and he says this is real one. So obviously that's not a good idea. I mean, that guy will not be very much trained. So initially loss value will be very high, but as you move along, as you improve training of discriminator, this loss value will be, suddenly coming down. So we say to the adversarial, we give these noisy images, and we say that, label is 1. It is just like this stage. It is this stage. So we say, here's the noisy image which we have generated, right? Tell us the label, right? Label is 1, tell us the loss. So obviously then it starts improving its loss value, kind of reducing its loss value, right? We print the log, right? And then we say, if in this iteration divided by 500 equal to 0, it means that this is the 500 interval time. So we do nothing at that stage. When this is true, we say show, and then we plot images, right? When we plot images, to the plot image we send generator, we send noise input, and show equal to true, and step is equal to 500 or 1000 or 1500, whatever, and let's see what plot is doing. Plot is doing nothing. Plot just takes generator, takes noise input, and then obviously show will be true because we are turning it true from there. So here we do nothing. We just say this is my save directory. I will be saving in my drive and gain model, my drive and gain model. Yeah, this one. This is the directory. Yeah. So I control A and delete all of them. I remove all of them. Right. So I will be saving those images here. Right. So here I say, creating directory, give it this name, image equal to generator.predict. So what we are doing, to generator, I give the noise input and I say give me image. So whatever image it is giving me, I'm going to display that image, and that's all. Right. And then finally I call this train and build model method. So let's run it, and I now call this method. It's doing nothing. It is just invoking this whole process. This might take some time, so we can at that time develop our more understanding. Yes, Irfan, you have got a question? Go ahead.
Yes, sir. I was asking for loss. You said 0. Initially it would be 0, but initially it would be high, right? For discriminator.
Can you say it again?
Sir, you said that initially the loss value will be 0 for adversarial to compare with the images generated by
loss will be very high. Loss will be very high. Loss will be very high. I mean
right.
Loss value must be high so that we can improve upon that. You can see here, loss value is initially 0.69, and then we are improving, and then slowly, gradually we are improving. Right. Clear?
Yes, sir.
So you can see all these summaries. So this is the summary of discriminator. It is the same model. as we have displayed it here, right? Our discriminator is this one. You can see this summary, and then this is our generator, right? So it is this summary, right? And then we put both of them together. So we have got this adversarial. This one is adversarial model, which I've got both the generator and the discriminator. The generator and the discriminator. And then we are just running it. So after 500 steps, you can see if you display every step, you know, a lot of data. So after 500 steps, I'm saving this, and I save it in my GAN model with 00500.png. So you can see 00500.png. So initially, it has generated this image. I mean, after 500 steps, after training our discriminator and adversarial for 500 step, you can see the generation quality is not very high. It's not very good. It is not very understandable. But as we move along, hopefully, you know, it will be improving. But you need to understand, this shape has been generated from random, you know, pixels, initially random pixels. So certainly, now you can see it is started learning how to write. Even though these are not very accurate, but after 1000 steps, you can see some, you know, shape is taking. Maybe this is 7. But slowly, gradually, as it sees more images, it is understanding how handwritten digit should be generated. I mean, it is just like when you are 2 or 3 year old, when you are shown a currency note, even it is written Eid Mubarak, but you feel happy about that. But when you grow older, if someone is giving you Eid Mubarak 10 rupees, you might slap on his face. You'll say this is fake. And you can do it because you have been trained. Because you have been trained to differentiate between fake currency and real currency. So same is the case here. As the network grows older, it has started, you know, writing better. You can see 2, really 2, 3, 8, 7. This really is 9. This is 5. But you know, after 1500 steps, it has started, you know, making more sense of these images. And remember, in each step, we are just training model on 64 images. We are training model on 64 random images from MNIST. 64 random images from MNIST. Right. So you can see when we run the loop, every time batch size is 64. Batch size is, so you can see from 0 to training side, I mean from all these, take 64 images, size equal to 64. So those indices which we get here, on those indices, whatever images are, we are saving them in real images. So certainly those will be 64 images because batch size is equal to 64. So in one step, we are only showing 64 real images and 64 noisy images, the random, you know, fake images that we are generating from here. We concatenate, label for the real is 1, label for the fake is 0, right? Train discriminator, right? Display its log value. Then once, if we in this step, if we have already trained it, we say generate noise, another 64 images, right? Give them label 1, all of them the label is 1. So because this time, you know, we are in this step, so the label is 1. So label 1, and rather than training discriminator, we are calling adversarial. Remember, when we are in adversarial network, the trainable is equal to false for discriminator. That is the reason why during adversarial generation, you know, weights for the discriminator will be frozen. If we do not do that, you know, both are learning at same time, and that doesn't make sense. I mean, if you do that, you will never end. It will become a kind of infinite loop. I mean, it's just like you go to the banker says, let me ask my boss. So that doesn't make sense. So that is the reason why we trained discriminator.trainable is equal to false in the adversarial model, right? So here now we say that train on the batch on noisy images, and label is 1. Display the loss value. Display the log, and if it is divisible by 500, we just plot that image. We just plot at that stage. At that stage, we just ask our our generator to generate an image, and we display that image. We display that image. I mean, not one image, but actually 16 images. You can see we are generating 16 images. 16. 1, 2, 3, 4, 8, 12, 16. So every time we are generating 16 images. So those 16 images we are going to display. Right. I mean, we just feel that after every 500 steps, it must have updated its learning. That is the reason why we are displaying at that stage. And the total number of steps in this case are 8,000. Obviously, if you increase number of steps, its learning will be further improved. And also, if you've got bigger data set, maybe in this case you've got only 60,000 images, but if you have got 1 billion faces, 1 billion faces, as we have in that this person does not exist, they have actually trained on 1 billion faces, and then batch size can be 1 million. So obviously that training will take a lot of time, but it will be generating lot better images. But on this basic assignment, you can see after only 1, 2, 3, 4, 5, 6, 7 steps, it has already learned how to write 5, 2, 2, 8, 7. So you can see it's already kind of making good sense of this data set. It is able to generate all these handwritten numbers. Right. Any question up to this point? Irfan?
No, sir, clear.
Irfan, Hasib, Irfan,
Clear, sir.
Abdullah, Basharul, Manisha. Manisha, are you there?
Yes, sir.
Okay. Were you there when I asked a question from you? I think no.
No, sir. Because of poor internet connection.
Okay. Great. So you can see after 4,000 steps, it's already making sense of these numbers. 4,000 steps, I have said 8,000. So it should be finishing execution in next 5 to 10 minutes. In the meantime, I just hope that you have fully understand the code of MNIST. Do you have any questions? Any query? Irfan?
Sir?
You just observe the output.
Sir,
Yes, Irfan.
no, sir, no query.
Okay. I mean, if you only observe this output closely, a lot of questions can be generated. A lot of questions must be asked, must came to your mind naturally.
Sir?
Yes?
Sir, is there any possibility that a generator may be generating same data as we have existing one?
This is exactly what I wanted some of you to ask. Thank you, Khalid. Thank you for asking this question. That is the reason why I showed you this output. You can see the generator is generating numbers at its own will. 1, 3, here it generated 2, 8, 8, 9, 1, 5, 5. I mean, in some cases, even these outputs are being changed. Here it generated 6, here is 6. I think here it was 9. It is 4, it becomes 9. It's a 3, maybe it's 8. And this was 2, this becomes 8. So obviously, as Khalid pointed out, if say for example, Just imagine, if you want to generate mobile number or maybe a check, a bank check written by me in my own writing, and if you've got a lot of samples from my writing, and if you have trained it, now you want to fill the check portion where you need to write the amount. Now if you want to write amount of rupees 500,000, so you would like to generate 5 then 0 then 0, in that case you would want to have better control on that rather than network generating on its will. You want that network should be generating the numbers that you are requiring. That is where we have this concept of conditional GAN. That is where we have, this was DC GAN, deep convolutional GAN, but now you've got a conditional GAN. In conditional GAN, you do nothing, you just concatenate this with a 10-dimensional one hot label. If you want to generate 0, then this should be 1, everything else should be 0, right? If you want to generate 1, this should be 1, everything else should be 0. If you want to generate 9, this one should be 1, everything else should be 0, right? Both of them are being concatenated, and then same is actually given to the discriminator. Only these two changes, then you will have better control on what you want to generate. You will have a better control what you want to generate. I'm not going to cover this conditional GAN fully in this class. Yes, Irfan, go ahead.
Sir, I mean, if you develop model like this, so you are limiting it to generate only numbers, right? Between the range of 0 and 9. What if you say suppose like you said in assignment generate a frog, so will we limit our network to only generate frog from those
you're right. I mean, see, when you are training the
model, you will
model,
develop conditional GAN.
Yeah, in conditional GAN, when you are training it on numbers from 0 to 9 in one hot encoding, the label, let me write it here, right? So the label for 0, for 1, for 2, for 3, for 4, for 5, for 6, for 7, for 8, for 0, the label is 0, 0, 0, 0, 0, 0, 0, 0, 0, right? Another 0, right? So, yes, for 0, how many? 10, yes, right? So for 0, for 0, this is the label, and for okay. For 0, this is the label. For 1, you know that this is the label. For 2, this is the label. For 3, in one hot encoding, this is 3, and this is 4, and this is 5, right? And so on, and so on. If you see in cipher, 0 is the label. If you see again in cipher, there are 10, different classes. Cipher 10. Cipher 10. This is a data set. Cipher 10, in which we have these things. Truck, ship, horse, frog, dog, deer, cat, bird, automobile, and airplane. So for airplane, the one hot encoding is 0. For automobile, it is 1. For bird, 2. For cat, 3. For deer, 4. For dog, 5. For frog, 6. Right. There, you would like to have one hot encoding for 6. One hot encoding for 6. Right. If you only concatenate this with your random noise and same to the discriminator, you should only be focusing on frog. So it will always be taking, new samples from the data set for only a frog. It will only be focusing on frog, nothing else. Right. So here it is just nothing. It says that do not take any other sample, just take samples for the class we are focusing upon. So here we will only be focusing upon frog. In this case, if I say generate only 5, it means that you are only focusing on the images which are for 5. So obviously in that case, the whole world for your discriminator will be one class. It will not be focusing on remaining objects, only the object that you want it to refer to. So obviously now if I ask you, can you generate 0331279 in my handwriting? You should be able to do that. If you have seen my handwriting, maybe 1 million instances of my handwriting, you should have my all 0 to 9 available to you. Then you can, through conditional GAN, you can focus one class at a time and you can generate those images. This conditional GAN, if applied in our previous text generation assignment, you will say that generate instances only for positive class, generate instances only for negative class, generate instances for only neutral class. Or even if you can go take it further, generate instances for sadness, for surprise, for happy. You've already seen that data set. So that CGAN, the conditional GAN, if trained properly on text, it should be able to generate more instances for those class label which do not have sufficient instances. And I can absolutely guarantee you that this type of this angle of GAN for text generation has not been explored much. So there is a lot of potential that you can use GAN for text generation. Yes, there is text GAN in literature, but it is just one dimension. If you read it properly, if you review it, I can absolutely guarantee you that this GAN has got a lot of power to improve text generation. Clear? So if you see this, after 8,000, you can see a lot of improvement. But obviously this handwriting can further improve if you increase batch size, number of training instances, and steps. Here I finished only after 8,000 steps, but you might continue further. In this case, you can see it stops after 8,000 steps and the output is displayed here. But certainly you can increase number of steps, and in each step, if you increase number of images, the training will be further efficient. Clear? Clear?
Yes, sir.
Yes, sir.
Okay, so I stop here. I just, I don't need to now read this assignment. I've already explained this to you. I will be sharing this code with you. Rather, this code is available on GitHub. So you just read the book. Book I have already uploaded. It's also available on our course LMS. This is the book, Advanced Deep Learning, right? So I think it is chapter number deep learning. Okay, this should be here, right? Okay, this book. So this is the book you should be reading, autoencoder and GAN from this book. So again, you just finish this chapter and you just Google GitHub with the name of the code which is written here, DCGAN MNIST. So you just write in Google, you will be taken to the GitHub. Rather, GitHub link is also given here. The GitHub link is also given here. So this complete code is available. You can take it from there. The only thing that I want you guys to do, work on Cypher. You can see that I have generated frog. I have been able to generate frog. Not only frog, but I have been able to generate car as well. So I have done it first and then I'm assigning you. You can see here GAN model 1 and model 2. So GAN model, this is 1, I think should be here. Images GAN 2, images GAN. So here I was generating a frog, right? You can see here, I was able to generate frog. I was able to generate frog. Initially noisy, completely noisy. You can see this is the initial one, but then it improves. Slowly, gradually it improves, right? And then in my second attempt, I was able to generate car. So here, image underscore gain underscore 2. So this is the car. This one is car. But then slowly, gradually, as it moves forward, this one is generated, this one is generated, this one is generated, this one is generated. So you can see slowly, gradually, it is taking shape of the car. At least wheel is there. At least wheel is there. So you can see I'm able to improve upon my generation.
Wheel is the main part, sir.
Yeah, wheel is main part, absolutely. But just imagine, I mean, in Cypher and MNIST, we've got only around 60-70,000 images. But this person does not exist. This person does not exist. They actually have, I think they have written it somewhere here. Yes, here, implemented on this in Keras. Do not panic. I think somewhere they have written how many images. I think 1 billion. So on 1 billion faces, if they have trained, they've got a lot of data. So they were able to generate, these high quality images. And remember, in our case, we are generating 28 by 28 by 1 because we've got limited computational power, but they are generating high dimension. This dimension is, I think, 2048 by 4048, I believe. So certainly these images are a lot better in quality. This GAN can be used not only for generating images, but also increasing resolution of an image, also removing noise from image. If you just take GAN as your thesis idea, you can take a deep dive into it, and a lot of variations are here. You can do absolutely amazing work in image generation or text generation or noise removing or colorization. All these are very exciting area to work upon in the context of GAN, right? But for the time being, just focus on this. Just focus on this. In the last class, we covered DCGAN. We are able to generate images of handwritten digit by training discriminator on MNIST. We, however, did not have control as to what next number is generated by the model. In order to get this control, you need to understand CGAN. Please read the relevant literature of CGAN from different sources, including the book we refer for GANs. This book. The objective of this assignment is to implement CGAN on MNIST to ensure the model generates digit 7, only 7 and nothing else. Display generation after 1,000 steps and do it for 20,000 steps. Repeat this for cipher 10. This time you need to ensure model is generating a frog. Do it for 20,000 steps and the byte size is 20. The display after every 1,000. So I have not written it here, but it is implicit. After every 1,000 steps, display what you have generated. Right. Once you complete both tasks, you should submit generated images along with the code on LMS. The submission deadline is Jan 13. Okay, so that actually marks end of the course. DCGAN. I'm not going to cover all these things. These you will do on your own. Just 2-3 slides and a couple of pages from the book. So I want you to cover it on your own because I want you to complete the assignment. Any question before I move to a quick review of your whole course?
No, sir.
So I have one question.
Yes, go ahead, Basharul.
So recently there's an area becoming, I mean, people are using like waveGAN for sound generation. Like using the audio signals they used to generate sounds. Is it a good area to work with?
I think Noreen is working on that. I kind of very stressed on Noreen that you must work on that, because she had very limited, sound, available for the cough. She will be generating cough, because they claim that for those guys who are having COVID and those who do not have COVID, their cough sounds differently. So she had lot of samples for those people who did not have COVID, but she had very limited, samples for those people who had COVID. So I said for this positive class, you should generate cough sound. So she is focusing on gain for sound generation, but that is an area which is not very much explored. I mean, just imagine sound generation means you can generate music. If you are able to train your model on all the music of A.R. Rahman, then your model should be able to generate a new music of A.R. Rahman, a music which will look like, composed by A.R. Rahman. The good thing is, remember one thing, sound is a sequence. It's a sequence. When you see sound, it's a sequence. Uh, from digital perspective, these are just numbers, right? One number coming after other. When you open any sound file in a text file, you will see that these are numbers. So when these numbers are given to sound player, it will be interpreting it differently and playing some music. So if you can train gain on those numbers, on those sequences, then it should be able to, generate a new music for you. And that is an exciting area. I mean, when you read different literature, they will say that a musician will also lose their job, because music composition is another area that machine learning is very much interested in, and GAN is one way of doing it. So yes, that is an exciting area.
So one more thing, when it comes to deep fakes, nowadays people are using GAN along with deep fakes, but there's a widespread concern how to reverse engineering it. Like many people are using it for offensive things. So is there any way that we can counter to detect or to reverse engineer, or is there any policies for it?
I'm not aware of it. I mean, just threat is there. I mean, that is the reason why GPT-3 has not been released fully. I mean, they have written very explicitly that we are afraid that people will misuse it. I mean, Harari says that we are very slow in legislation. They say that the way we legislated that atomic energy must not be ordinary use. So same sort of legislation we should do for AI. So he said we are a bit slow. AI is already taking control of our life, and still our legislators are sleeping. So he said, otherwise, even atomic energy, it's not a big deal. Every country can become an atomic power. Uh, I mean, all the formulas are written on Google. You know how to build it, how to create it, but you cannot, because there is world legislation on that you cannot do it. The way we had those chemical weapons, developing a chemical weapon is not a big deal, but world has got legislation for that. So same should be for AI, but up to this point, no. I mean, reverse engineering doubts are always there. Only some responsible people do not release fully, otherwise everything is open source available. So yes, these are very dangerous times. We don't know how AI will be playing, but threat is always there. More questions? Okay, just a quick recap of what we have been doing throughout this semester. If I just see the course outline, many things we have already, rather everything we have already covered. I mean, we started with the basics of AI. We started with the first chapter of the book, We started understanding basics of neural network, introduction to keras, classifying movie reviews, classifying news by a multi-class classification. Then we discussed about basics of machine learning, all these overfitting, underfitting, these concepts. Then deep learning in practice, we actually shifted our focus on computer vision. This is where we were introduced with CNN, right? Training convolute at small data set, using pre-trained convolute and visualizing what's happening at each step. So when this course has been concluded, now I can very confidently say that my students can easily work with image classification by using deep learning. This statement will not be wrong, Irfan?
Yes, sir, absolutely.
And then we shifted our focus on text. We understood what is RNN, it's mathematics. Then, we saw generative deep learning, we saw LSTM, neural style transfer. These are some, beautiful ideas we have not discussed in class, but I strongly recommend that you isko bhi thoda dekh le. Generating images with the variational encoder we could not cover because of time limitation. And then we covered, GANs, right? We covered, all these things, autoencoder, denoising, colorization, GAN. We also saw all these word embedding. We understood transformer, attention. I don't think I've written those here, but BERT is actually having this concept of transformer, so it is implicitly written. And then GPT-2 and 3, and I don't need to discuss these because we have been discussing it throughout, latest trends in NLP, image classification and video processing. I'm expecting some exciting projects from you guys. The way forward is simple. I mean, now you can play with text, you can play with images, you should be able to play with video. That is one area I'm still learning how to do it. Maybe next semester when I teach deep learning again, I will be introducing that part as well. This time I could not because not a lot of literature is available on that. I have tried a couple of times but failed, but I'll keep trying to introduce the video part in my deep learning course. Hopefully next semester that will also be aided. But the way forward for you guys is to just develop your interest in one of these areas: image mining, video mining, text mining. You've got tools for those. Do in-depth literature review, and then the sky is the limit. One big success story of this class is obviously our small group of Irfan, Nimra, Saif, and Khalid. We started very humble. This idea actually was developed in class from that BBC assignment for text classification. But these four guys have been restless. I mean, they have not slept for past 2 months. Every day, all these four guys are spending, many hours, lot more than what I expected. But now, when we discuss on that simple idea, we are very much confident that 4 to 5 impact factor publications are probably the smallest outcome from that simple idea. And Irfan usually says at least 2 MS theses, though I do not agree on that. But
yes, sir. I absolutely guarantee you.
But I can guarantee that 4 to 5 impact factor publication from the idea that we developed in class. It is just one idea that we matured. A lot of other ideas will be getting from you guys when you'll be submitting your final projects. Each of these ideas have got fantastic potential to become a master's thesis or a good impact factor publication. Yes, sir.
Sir, you were talking about video processing and deep learning. So I've seen is that there is no any direct model which directly takes video as an input. Basically, it is like framing. You have to do framing first of all. So I don't know why there is no any model which directly video as an input and works on it frame by frame automatically.
You know why I say there must be one? Because of this reason. See here, because of this reason. I say that there must be, because matrices, 3D tensor.
Hasib, mute your mic, Hasib.
Yeah, they discuss real world example of data tensor. Let's make data tensor more concrete with a few examples similar to what you will encounter later. The data you will manipulate will almost always fall into one of the following categories: vector data, time series, image, and video. So 5D tensors are nothing but videos. There is a concept of 5D tensor. Now, if there is concept of 5D tensor, they say when it is 5D tensor, it means that you will have some video samples, frame from each of the sample, and image in each of the frame. So I mean, this concept is there. This concept is certainly there. This book is not discussing it very much. You can see, for instance, a 60-second 144 by 256 YouTube video clip sampled at 4 frames per second would have 240 frames. A batch of 4 such video clips would be stored in a tensor of shape, 4 sample at 250 frame per sample, each frame of 144 by 256, and because they are color, so 3 RGB. So these are number of values, and 405 is the size of these tensor. So video you encounter in real life are much lighter because they are not stored in float 32. They are typically compressed by a large factor. Obviously, compression techniques are different, but they say in tensor you can represent video data. I think my common sense says there must be something. I mean, your CNN should be directly accepting videos. But if not, then obviously taking snap one image from one frame, that option is always there. But I would like you to explore on this, how to create this type of tensor which represents video. Yes, Hasib.
Okay, sir. Okay.
Okay. But as I told you earlier, you just increase your understanding of these concepts, a lot of ideas will come to you naturally. I just want you guys to explore further. Do not stop here, because this is just the minimum we have covered in this class. Just a small part in each of the concept. But if you further go in depth of these ideas, you will have a lot of other good ideas. I mean, just small idea in class, and when we gave it time, we felt excited, and we can see a lot of good outcome coming from our work. And because you guys are master's student, you will always be needing PhD scholarships, maybe in Pakistan or abroad. If you have got 3-4 impact factor publications with MS thesis, no one can stop you. A lot of guys are those who could not complete their MS with thesis. Now they are writing back to me that it was our fault that we did not complete our MS with thesis, and now we are unable to hunt international scholarship. So one, advice: complete your MS with thesis. And second advice, do not stop here. Just select one area which excites you. I mean, where you feel home, in text or in image or in video. Just select that part and do in-depth study. Do not rush to the idea. The idea will come naturally to you. Just increase your literature review. You can have an example of Ghafoor. I mean, Ghafoor, my God, I mean, it is just 12, 13 months in his MS. He has already defended his proposal, and I can absolutely guarantee by March he will have 3 to 4 publications. He is working with me, with our European friends. We meet every Saturday 2 to 4, and his progress is fantastic. And I'm very much confident by March his everything will be completed, because his thesis idea is what we all are working upon. His thesis idea is all what all sites we are covering, and all of us, the group member, are contributing. And I'm sure in 2 3 months from his thesis idea, he will have 3 to 4 impact factor publications. And when he enters into the hall for his defense of master, having 3 to 4 impact factor publication on his account, he will be very, feeling proud. His head will be very high that today I'm here for defense of my thesis, and I've already submitted, or I got published 3 to 4 impact factor publication. And having master's degree with 3 to 4 impact factor publication, the chances of getting scholarship becomes very bright. I can again share you a story of Sarang applied in UCD Dublin. He got a scholarship, fully funded scholarship. Because of COVID, they said come in 2021 March. He applied in NTNU Norway. He got fully funded scholarship. Not only tuition fee, but a lot of money for his stipend. Everything is covered in NTNU. So this is the second scholarship that he has won in just last 6 months. And the reason is very simple. He was always clear what he has to do. He actually chose deep learning on text. He produced 3 4 quality publications. He is still working with us. Another 3 to 4 publications are in pipeline. But when he applied for PhD scholarship, those who interviewed him, they were extremely satisfied, and they were very much surprised as well that we have got such quality of a student in Pakistan as well. So I don't see any reason why you guys, if focused properly, cannot, earn all these lucrative scholarships. Yes, Urdu News data set 1M. We have already kind of collected 1 million instances on Urdu News. We started with BBC News, the assignment that we had in class, but later, wow. Any other question or comment that you have?
Sir, exams.
Yes,
There's a message I get.
exam will be walk in the park, the way you had mid. I mean, I mean, when I was conducting your mid exam, 1 week before your exam, I conducted data science exam, and the highest score was 8 or 9, and average was around 5 out of 20. So that actually I was totally, what should I say? My moral was very down. I said there I gave very difficult exam and no one performed. So I was in very much safe zone. So I gave you exam which was extremely easy, and I can see everyone score 18, 19, and 20. So this time, on coming Friday, I'm again planning same thing, and the exam will not be very difficult. I want you guys to focus on this assignment. I want you guys to focus on your final projects. Exam will be something walk in the park if you have covered everything properly. If you can, play with the text, LSTM, fast text, glove, bird, transformer, attention, CNN, GAN, text generation, LSTM. So, and if you have done all these assignments, you must have already done a lot of practice. If you have already done a lot of practice, you should have all those codes available with you. What I can give you outside that, I mean, I do not really have, many options. I can only give you some data set you can play with. The only thing is you need to do a lot of homework. When you come for the exam, You should have all these sample, you should have all these codes accessible to you, and you just need to play with the data set and then properly analyze it. So exam should not be difficult. If you are good at understanding the concepts, exam should not be a big deal. Focus on assignment and focus on your final project. Exam will be 3 hours. It is final exam, so it will be 3 hours. But again, it will be something which we have already done in the class. And the venue will be same where we met last time during mid. Okay, so
Thank you, sir.
Yes.
Sir?
Yes, sir.
Hello?
Yes, sir. Yes, sir. Yes, Irfan.
Yes, sir. Will be with text or images again in final?
There can be both. Because I will not be giving you just one question. These are 3 hours. So I can give you, practice for CNN and practice for LSTM, attention, all these things. So it will be both. Just small suggestion. Do nothing. Do a lot of practice. Just watch all these videos. Just recall what we covered, and complete all these chapters which we have covered from this book, and 2 chapters from the second book, and all the lectures are available on LMS. I don't think exam will be difficult. Exam will be very easy if you know the programming. If you do not know the programming, then exam will be very difficult. You know this, eh?
All right, sir.
So with this, yes.
Excuse me, sir. Sir, please kindly upload this recording because I couldn't attend class today. So kindly upload this recording.
Okay, I will do that. I will do that. Certainly.
Thank you, sir. Thank you so much, sir.
Okay, so we stop here. I will upload this, and if you have any query, you can still write on WhatsApp. I will be available. You can also send me email. But that is the last class of this semester. There were few more aspirations that I could not do because of COVID closure and because I was away for 10 days. So hopefully when next time I offer this course, I will be including video part as well. Again, a kind of a strong advice: do not go for MS with thesis, go for MS with coursework. I can show you email, but that will be kind of breaching privacy of some good student. But he wrote me 2 days back that he's regretting that he did not go with thesis, and now he cannot get scholarship anywhere because I do not have any publication. But those who did with thesis, they naturally had publication, and then because they had publication, so their chances were better. And I can absolutely guarantee you that these concepts, these ideas are very much current. They are very much exciting. A lot of opportunities are already there. You just need to properly with focus search those. You should be able to. I mean, if Sarang can do it twice in 6 months, why can't we all, if we have 3 or 4 publications on our account? With these words, thank you very much. See you on coming Friday for your final exam. Allah Hafiz.
Allah Hafiz, sir.
Thank you so much, sir.
Thank you, sir.
Allah Hafiz.
Thank you.
Thank you, sir. Allah Hafiz.